In this video, we'll discuss the beginning of number systems. Now, before we can talk about number systems, we first have to talk about the concept of numbers, because numbers have only been around, as far as we know, for about 50,000 years. And when they started, it was a general number sense, not actual numbers. However, as time went on and we changed to different types of civilizations, we had to keep track of things using numbers. Some of the earliest types of markings we see related to numbers are tally marks that are one-to-one relationships, kind of like on the Ashango bone, which is used for keeping track of herds. And so like for every tick mark or tally mark on the bone would represent one sheep in the herd. The problem is this becomes very cumbersome, because what if one disappears, or say that one dies? How do you remark that on the tally marks that you have, and how do you keep track of that? So our number systems then begin to evolve to be more complex. To do that, civilizations came up with different bases for different reasons. Some of the most commons were either base 2 and base 5, base 60 and base 20, depending on the different civilization. But most commonly, what you will see is a base 10 system in many civilizations. And you think about, well, why would that be the case? Well, think about what we have. We have two hands that have 10 fingers total. And whether or not that's the best system, it's the one that's most commonly used for that very reason. So when we think about how do the systems evolve, we know that we started first with words and verbalization and using fingers to count, but then that becomes challenging as well because there's no record of what is being done. So symbols were constructed to help create these number systems and be able to pass them on longer term. Different cultures use different systems, and that's important to recognize. For example, we have simple grouping systems, multiplicative grouping systems, ciphering, as well as the positional numeral system. So let's look at these individually. In a simple grouping system, a base is adopted, and then there's a symbol for 1, and then that base, and then each power of that base. Numbers are represented additively. So when we think about different systems, you'll see that they have lots of symbols and their numbers look really long because of that additive nature. For example, the ancient Egyptians' hieroglyphics were base 10 simple grouping. Now, we'll often put our numbers in order by least to greatest, but they didn't worry about that. So their symbols could be in any order, and you had to recognize the combination of them created whatever number you had. So here were the common symbols up through 1,000,000. And what they would do again would be additive. So let's look at some examples. If we see here we have 3 tadpoles, 1 lotus flower, 2 heel bones, and 4 staffs. That would be 300,000 plus 1,000 plus 10 plus 10, so that's plus 20, and then plus 4. So that would be 301,024. Or maybe we say we want to actually construct a number. We want 3,214,563. For the 3,000,000, we need 3 of our astonished men. For the 200,000, we need 2 tadpoles. For the 110,000, we need a pointing finger. For 4,000, we need 4 lotus flowers. For 500, we need 5 coils of rope. For 60, we need 6 heel bones. And then for 3, we need 3 staffs. And see how long that number is, but that's because of the additive nature of simple grouping. The Roman numerals also used grouping with a base 10 system, and they had symbols though for 5, 50, and 500 as well, so that there wouldn't have to be such long numbers. The original Roman numerals were purely additive, so it would go out all the numbers just like we saw with the ancient Egyptians. Later came the subtractive numerals that we think of, where if we put an I before V or X, we're taking 1 off. If we put an X before L or C, we're taking 10 off. And if we put a C before D or M, we're taking 100 off. So let's look at the number 1,749. In the original Roman numerals, we would have, let's think about our groupings. We'd have 1,000, we'd have 500, 2 100s because that would give us the 1,700, 4 10s to give us 40, a 5, and then 4 1s. So we think about our symbols, that would be M, D, CC, XXXX, V, I. Now, when they think about 600 years later with a subtractive, what would that look like? So we have now the ability to use 900, 400, 90, 40, 9, and 4. So we think about, well, where can that help us? So we still have the 1000, the 500, and the two 100s, but now we can actually do 40 versus having to do 4 10s. And now we can do 9 instead of having to do a 5 and 4 1s. So this will become then MDCC, and then 40 is XL, and 9 is IX. The next system that is very common is the multiplicative grouping system. Here we have symbols for our base that go from 1 to b minus 1, and then we have a second set of symbols to represent the powers of that base. And we will multiply them by a symbol to help us represent a very specific place value, kind of like our expanded form. This is very common in the traditional Chinese and Japanese numeral systems, but one of the key things to recognize is that anytime we write them in that form, we also write the numbers vertically. So here we have the symbols 1 through 9, and then we have the power of 10, 10 squared, and 10 cubed. So if I wanted to write the number 5,627, I start with the numeral 5 times 10 to the third. And then I'm going to do 6 times 10 squared. And then 2 times 10, and then plus 7. So here would be 5,000, here would be 600, here would be 20, and then I'd have my 7. Let's look at another number, say 3,084. Let's do the same thing. We've got 3 times 1,000. We don't have to put the 0 because they don't have a 0 symbol, so we just go to the next place value, which is 8 times 10, and then the plus 4. So 3 times 1,000, 8 times 10, and then the symbol for 4. Now another common system was called the ciphered numeral system, and here we have to create symbols both 1 through b, but then we have to start creating symbols for all the multiples after that. And it becomes a lot of symbols, and that becomes cumbersome as the numbers get larger. Some different systems would also go through and put different types of markings to represent when you go to like the 10,000s, the 100,000s, like the Ionic system created by the Greeks. They would use little tick marks by things to help say what it is when it gets beyond 1,000. And that can be kind of hard to see at times when you look at ancient scripts. So let's look at our own system. Because they use the Greek alphabet, we're going to say, let's use our alphabet now. If we say A through I is our symbols 1 through 9, J through R will represent 10 through 90, S through Z will represent 100 through 800, and then we'll use the symbol at for to represent 900. That at least will get us through the ability to make the numbers 999. So let's create 832. If we think about our symbols and how that would go, the 800 would fall to the symbol Z. The 30, we go through here, JKL, so it would fall to the symbol L, and then the symbol 2 would be B. So 832 in this symbolic system or the ciphered numeral system would be ZLB. Again, that was just to get through 999. And look at that, we have 27 symbols already. That's some of the challenge when you think about a ciphered numeral system. Then that led to the idea, though, of the positional numeral system. Here we create our base. We have symbols, sometimes 0, not always, depending on the civilization, but those symbols would then go up to b minus 1, because then b would create the next positional place value. We put our numerals in that given position in, and they're understood to represent the place value times the base to the power n minus 1. So we think about our system in the US, we use the Hindu-Arabic numeral system, which is base 10. It's been around since the late 800 CE. This, we think about positions from right to left. We read the numbers left to right, but the positioning is right to left. So the greatest value is on the left-hand side. So if we think about what does 547 mean in the Hindu-Arabic numeral system, this means our base we have is 10. The 5's in our third position, so 5 times 10 to the 3 minus 1, that n minus 1. So that's 5 times 10 squared, or 5 times 100. The 4 is in the second position, so that's 4 times 10 raised to the 2 minus 1, or 4 times 10. and then the 7's in the first position, which is times 10 to the 0, or 7 times 1. That's why we think about it in that expanded form. That's 5 times 10 squared plus 4 times 10 plus 7 times 1. That's what the number means, even though we write it in this positional system. And it's important to recognize there have been many positional numeral systems throughout the decade, or throughout the millennia. We have the Babylonians who use a sexagesimal system. One of their biggest issues, though, with their positional numeral system is that they had no 0. So they had to use different ways of representing when nothing was there, and that sometimes causes issues in understanding what were the numbers being created. The Mayans had a base 20 positional numeral system that was from around 1000 BCE, and they eventually included 0 around 357 CE. And now we use the Hindu-Arabic numeral system, and that came around 800 CE, and it did include 0. And that was a huge step forward, being able to say that there was nothing in a given position. Now, when we think about positional numeral systems versus the multiplicative grouping systems, they are very similar. The way that we often think about it is that the positional implies place value in the given places, whereas the multiplicative explicitly states place value. In the United States, the positional numeral system we call the decimal form, whereas the multiplicative grouping we call the expanded form when we want to show explicit place value. So when we think about the number 6,784, if we're going to go to that expanded form or the multiplicative grouping, we'd say it's 6 times 1,000 plus 7 times 100 plus 8 times 10 plus 4 times 1, which can help build understanding of what that positional numeral system means.